Today class we will discuss regarding the duct propagation and M curves. What is this duct propagation and what is this M curves? Okay. So the definition of the duct propagation is a radio signal which follows means generally for transmission of VHF signals, we cannot use ground wave or sky wave propagation. Okay, so even though it is not possible by line of sight propagation, even though we are transmitting that signals using other type of propagation, it is called as duct, duct propagation. Okay, so basically here, despite being diffracted from the ionosphere or gliding over the surface of the earth, the waves propagated from an end to another by undergoing successive refraction from the troposphere. Successive refraction from the troposphere. Okay, so duct propagation is sometimes the other name of the duct propagation is it is also called as super refraction. It is also called as super refraction. Okay, so it allows the propagation of the signals beyond the origin, which means that unlike surface wave propagation, it permits the signal transmission without assuming the need of having a line of sight distance between the two atoms. Okay. Without the need of having a line of sight between the two. And what is meant by line of sight? So from the transmitting antenna, compulsorily the tip of receiving antenna should be visible, or no obstacle should be present between transmitting antenna and the path of transmitting antenna to receive. Even though that is not, even though if LOS is not possible, we can transmit the signals. Okay, so this is the formation of duct, how the signal is trapped and will follows the reaches from transmitting antenna to receiving antenna, we will see here. Okay, so in this we cover M curves also. Okay, so in duct propagation, so in order to get understand of duct propagations, so radio signals follows a particular channel is called as duct. Radio signals will follow a particular channel is called as duct. Okay, so in order to understand the duct propagation, first of all, we should have a clear idea regarding M curves. We should have a clear visualization regarding M curves. So let us discuss what is meant by this M curves. Okay, so for standard atmosphere, we will have normal refractive index theta. But for non-standard atmosphere, So first of all, what is meant by standard atmosphere and what is meant by non-standard atmosphere? Standard atmosphere means, for example, this is my Earth surface. Let us consider this from here to here. It is standard atmosphere. The standard atmosphere means as you are going above the Earth surface, the temperature decreases. So this is standard atmosphere. What is non-standard atmosphere means? Generally, as you are moving up above, the temperature should decreases. But for example, if you consider this is non-standard atmosphere, as I am moving above the Earth surface, here the temperature increases. Okay, so where the temperature increases along with height, that is called as non-standard atmosphere. Standard atmosphere means as you are moving above the Earth surface, the temperature decreases. So for standard atmosphere, the normal refractive index theta is sufficient. For non-standard atmosphere, we should have modified refractive index. Okay, so the modified refractive index is given as N. N is equal to theta plus H by R. What is this theta? Theta is actual or normal refractive index. What is this H? H is height above the Earth surface. H is height above the Earth surface. Height above the Earth surface. What is this R? R is the radius of the Earth. What is the radius of the Earth? It is 6370 kilometers. The radius of the Earth is 6370 kilometers. Okay, so the modified refractive index N is equal to theta plus H by L. So if we observe here clearly, the value of here modified refractive index is approximately equal to 1. Why? Because why the value of modified refractive index? So for air, the refractive index is 1. And if we observe here, R is very, very greater than H. So it is almost 6,000 kilometers. Okay. But height of the antenna will be in 1 kilometer, less than 1 kilometer. So in that case, the value of N is almost equal to 1. Okay. So it is equal to 1. So now we want to calculate or want to consider the excess modified refractive index. We want to consider the excess modified refractive index. To consider excess modified refractive index. Refractive index. So plus modified refractive index. So modified refractive index, the modified refractive index is denoted as M is equal to N minus 1 into 10 to the power of 6. M is equal to N into 10 to the power. How will you get this modified refractive index? What is the formula for N in the previous case we have taken eta plus h by r. So first I am subtracting 1 from both sides, that is eta minus 1 plus h by r. Next I am multiplying n minus 1 into 10 to the power of 6 is equal to n minus 1 plus h by r into 10 to the power of 6, which is nothing but n. So therefore, the value of M is equal to modified excess modified refractive index is equal to N minus 1 into 10 to the power of 6. That is equal to N minus 1 plus H by R into 10 to the power of 6. 10 to the power of 6. So to understand the duct propagation, we want to learn about regarding M curves. So what is this M? This is excess modified refractive index. So what is meant by M curve? What is meant by M curve? Okay, the curve with respect to the plotting of the curve with respect to M with respect to H. M with respect to H. It means height above the earth surface. This is nothing but M curve. Okay, the curve what we are plotting is with respect to M with H. M with H is called M with H is called as M curve. Okay, so when we plot M against H or M with respect to H, we call it as M curve. Okay, so to understand the duct propagation, let us study regarding M curves. Okay, so M curves are plotting the modified refractive index. M curves are nothing but a plot of or plotting. M curve is nothing but plotting of modified refractive index M. Modified refractive index M with respect to H. This is called as M. This is the definition of M curve. Plotting of modified refractive index with respect to M is called as M curve. Okay. So see here, for non-standard atmosphere, simple refractive index does not matter. For non-standard atmosphere, simple refractive index, simple eta does not occur. So, but when M curves are available, it is possible to predict roughly. Okay. So the gradient, what is meant by the gradient? The gradient means differentiation of M with respect to H. Okay. And the gradient means nothing but the curve with respect to differentiation of M with M curve with respect to H is nothing but the gradient, and the sign of the gradient depends upon, and the sign of the gradient, and the sign of the gradient depends on the tropospheric condition. Tropospheric condition. Tropospheric condition. So let us discuss regarding the inversion layer. What is this inversion layer? Okay, so what is this inversion layer? So the definition of the inversion layer. Okay, so let us study here. So what is meant by the inversion layer? The inversion layer is a region where the atmospheric conditions are exactly opposite to the standard atmosphere. Okay, so what is meant by inversion layer? The inversion layer is a region where the atmospheric conditions are exactly opposite to the standard atmosphere. Okay, so see here, for standard atmosphere, the slope of m with respect to is positive with respect means dm by dh is positive for standard atmosphere. Okay. So whereas for inversion layer or non-standard atmosphere, dm by dh is negative. dm by dh. Okay. So the slope of m is dm by dh is negative. dm by dh is negative with respect to h. Okay. So this inversion layer, okay. So in order to form the duct, the inversion layer plays a important role. So for inversion layer is referred to as duct layer. Inversion layer is referred to as duct layer. Okay. So, so for inversion, for standard atmosphere, the slope of m with respect to h is positive. For non-standard or for inversion layer, the slope of m is negative with respect to h. Okay. So the inversion layer is also called as the duct layer. Inversion layer is also called as duct layer. Okay. So let us plot the graph. Let us plot the graph uh, with respect to m and h. Plot with respect to m and h. Let us plot the graph with respect to m and h. Okay, so see here, for example, let us consider this is a graph between m versus h. M versus h. Okay, so for example, let us take standard atmosphere. Let us take for standard atmosphere. So for standard atmosphere, the slope is positive. The slope is positive. The slope is positive. The slope is positive. This is for standard atmosphere. For non-standard atmosphere, so how will be the M curve? The curve for non-standard atmosphere, the curve is negative. The curve is negative. Okay. Means for standard atmosphere, the slope is positive. For non-standard atmosphere, the slope is negative. The slope is negative. The slope is negative. Okay. So similarly, let us see here for both combination of standard and non-standard or inversion layer, non-standard atmosphere or inversion layer graphs. Okay, so I am drawing a graph. So this is between here. Let us consider this is m and this is h height above the earth surface height. So let us consider up to here there is standard atmosphere. There is standard atmosphere. Okay. So from here to here, there is inversion layer of non-standard atmosphere. Non-standard atmosphere. And again from here it is standard atmosphere. Again it is standard atmosphere. Standard atmosphere. Now how will be my graph? So for standard atmosphere, my graph will be for standard atmosphere, my graph will be so for standard atmosphere, my graph will be positive. Okay. My graph will be positive. Okay. So it is positive slope. So for inversion layer of a non-standard atmosphere, my graph will be, my slope will be negative. Negative slope. Again, for standard atmosphere, my graph will be positive. Again, for standard atmosphere, my graph will be positive. My graph will be positive. My graph will be positive. Okay. So this is a graph with the combination of both standard atmosphere versus non-standard atmosphere. Okay. So generally, what is meant by the standard atmosphere? Generally, standard atmosphere means, so see here, if you consider this is earth surface, okay. So as you are moving above the earth surface, okay, as you are moving the earth surface, okay, here the as you are moving the above the earth surface, the temperature decreases. Temperature decreases. Means temperature decreases means this is nothing but standard atmosphere. Standard atmosphere means as you are as the height increases, height above the earth surface increases, the temperature decreases. For non-standard atmosphere, as the height is increasing, temperature also increasing. As height is increasing, temperature is also increasing. That is non-standard atmosphere or inversion layer. Inversion layer. Whereas for standard atmosphere, whereas for sta- whereas for standard atmosphere, whereas for as height increases, temperature decreases. Temperature decreases. Okay, the height increases, temperature and decreases. Okay, so the inversion layer. Okay, so in this graph, the inversion layer is sandwiched between two standard atmospheres. Okay, two standard atmospheres means coming to here. So this is nothing but we can consider here the density. Here the density is less, and here the density in this inversion region, or in this inversion region, we call it as cool region. Okay, or we'll call it as cool region if you draw the same graph. Okay, so if you draw the same graph, okay, so this is the graph we have drawn. So this is standard temperature, inversion layer. This is again standard temperature. So this inversion layer is sandwiched between two standard temperatures, two standard atmospheres, two standard atmospheric conditions, two standard atmospheres. This inversion layer is sandwiched between two. So here this is nothing but cool region, and this is warm region. Warm air, cool air or warm air. This is cool air. And again, this is warm air. Okay. So warm air, cool air, warm air. Okay. So cool air have more density. Cool air have more density. More density means the dielectric constant is more than 1. Warm air have less density. Warm air have less density, of the dielectric constant goes on decreasing as temperature increases in standard atmospheric condition. Standard atmospheric condition. Okay. So means this is warm air. This is warm air. In between you are having cool air. In between you are having cool air. So due to this, the cool air is trapped between the earth surface and the cool air is trapped between. So see here, this cool air is trapped between earth surface and the warm air. Okay. So the region of cool air behaves like the duct. The region of cool air. The region of cool air. The region of cool air Cool air means the cool air is trapped between two warm air and the earth surface. Okay, so the region of cool air behaves like duct, like duct for radio waves. For radio waves. Okay, so let us discuss single hope and multi hope. Single hope duct propagation and multiple hope duct propagation. Single hope and multiple hope duct propagation. So when a signal goes from cool air to warm air, when a signal goes from cool air to warm air means, so see here, when a signal goes from cool air to warm air, okay, so it faces reflection and comes back to the earth. Again here warm air is there, reflection takes place and comes back to the earth. Okay, so let us see here what is meant by this single hope. And so let us draw this diagram. Let us draw this diagram. This is my earth surface. This is my earth surface. Okay, so okay, let us consider this is warm region and this is warm region. Okay, so let us consider this is my transmitting antenna. This is my transmitting antenna and this is my receiving antenna. This is my receiving end. Okay, so here what is there here? Let us consider here. There is nothing but standard R. We'll call it as warm air. Here we are having warm air, and here also we are having warm air. Here also we are having warm air. Here also we are having warm air. Okay, so this is warm air. Here also we are having warm air. Okay. So whenever a signal is transmitted, whenever a signal is transmitted from Earth surface, it enters here. What happened here? So cool air is having higher density and warm air is having lower density. So whenever the signal goes from cool air to warm air, it faces reflection and comes back to the receiver. Comes back to the receiver like this. Okay. So similarly, this is how many times the reflection is taking place. Here the reflection is taking only one time. Okay. Here the reflection is taking place only one time. So this is called as single hope duct propagation. It is called as single hope duct propagation. So this is single hope duct propagation. So let us take multi-hope duct propagation. Let us consider multi-hope. Let us consider this is my earth surface. This is my earth surface. This is my earth surface. Okay, so this is my earth surface. So this is cool air. So let us consider this is the warm air. And this is also the warm air. So this is warm air. This is warm air. And this is cool air. Here also this is cool air. Okay. So let us draw the diagram of antenna. Let us draw the diagram of antenna. So this is my transmitting antenna. This is my transmitting antenna. And this is my receiving antenna. This is my receiving antenna. Okay, so this is my transmitting antenna. This is my receiving antenna. Now let us draw the waveform. Okay, how the okay. Now let us see here. Now this Kool-Aid, the wave transform, radio transmission Kool-Aid, and it touches the warm air. So whenever the signal goes from cool air to warm air, it faces a reflection back, faces reflection back, and again here it again comes to the warm air. Again reflection takes place. Again come to the back and come takes place, and this and finally it reaches to the receiver. Okay, so here how many reflections takes place here? Here, how many reflections takes place? 1, 2, 3, 4, 5, 5 reflections takes place here. Here, only how many reflections takes place here? Only one reflection takes place. So this is called as single hope, and this is called as multiple hope. Okay, so clear? This is multiple hope duct propagation. This is multiple hope duct propagation. Okay, so when the signal goes from higher density to lower density, there will be transition pattern. So this is warm air have lower density, warm air have lower density, and cool air have higher density. So whenever a signal goes from higher density to lower density, there will be transition pattern. Okay. So what is the condition? Condition for to exist duct propagation is conditions for to exist. This is formation of duct. This is nothing but formation of duct. Okay. So condition for condition for duct propagation is condition for duct propagation is the condition for the duct. The first one is the transmitting antenna. The transmitting antenna should be inside the duct. The transmitting antenna should be inside the duct. Inside the duct. What I have told that this is nothing but the inversion region. This region is nothing but inversion region or cool region, or this is nothing but duct. This is nothing but duct. Okay. So this is nothing but duct. This region is nothing but duct. Okay. So this region is nothing but duct. So your transmitting antenna, this is my transmitting. Where this my transmitting antenna? My transmitting antenna is in the duct region. Okay, so the transmitting antenna should be in the duct. And the second one is the radio wave sent of the duct. The radio wave, whatever the radio wave that is entering into the duct, the radio wave entering into the duct, entering into the duct should have low angle of incidence. Should have low angle of incidence. Low angle of incidence. Okay. So this is how the duct propagation takes place. Okay, so this is how the duct propagation takes place. Means, for example, let us consider this. So this is how the signal will get trapped in the duct. This is our duct. This is our duct. Once the signal reached into the enter into the this duct, the signal may go so many reflections and finally reach to the receiver. Okay, so the trapped wave inside the duct. Okay, so this is how the signal may reach to from transmitting antenna to receiving antenna using duct. Okay, so this is my duct. Okay, so many reflections. Okay, if the reflection takes place, if the reflection takes place a single time, it is called as single hope duct propagation. If the reflection takes place many number of times here, so let us see here. Here so many reflection takes place. The same signal reflection has taken so many Right. So this diagram, it is multiple Hooke duct propagation. Multiple Hooke duct propagation. Multiple Hooke duct propagation. Okay. So this is regarding the duct propagation. This is regarding the duct propagation and M curves and M curves.